This is previous the tutor. I welcome you to this lesson. For those who want to do revisions for GCE, the classes are on, and you can contact me on 0978076090. Lessons are in progress. The earlier the better. So let's get started. 5.5 grams of calcium carbonate. They are saying it decomposes as shown. So when calcium carbonate decomposes, it forms calcium oxide and carbon dioxide. Of these numbers that you are seeing, they are supposed to be subscripts. For example, this is supposed to be carbon dioxide and not this, because I couldn't write it properly. Let's proceed. It says calculate the relative molecular mass of calcium carbonate. Now, what do you mean by relative molecular mass? Now, relative molecular mass is just the sum of all the, it's just the sum of what? All the relative atomic masses in that compound. So we are going to get our calcium carbonate, right? So I'll get calcium carbonate and I'll write like this. So I'm going to do this. Okay, all these are elements. I'm only doing this for elements. So how many oxygen atoms do we have? We have 3. Then go on the periodic table and check for the mass number of oxygen. You see that it's 16, and this should give you 48. How many carbon atoms are here? There's just 1. Mass number of carbon on the periodic table is actually 12, and this will give you 12. Calcium is 1 atom there. Mass number is 40, and this will give us 40 here. This should be able to give us 100. Now this is relative molecular mass, so it has got no units. So you just conclude relative molecular mass is equal to 100. Is that difficult to show? B says number of moles of calcium carbonate. Now, number of moles is given by mass of that same compound over relative molecular mass of that compound. And in this case, our mass given is this one here, 5.5 grams. We divide by relative molecular mass is here 100. And in this case, we are doing the number of moles, so we're going to include gram per mole. But other than that, you cancel. So we have 5.5 divided by 100, and number of moles will be equal to 0.055 mole. These are for calcium carbonate. Can you fail? No, I doubt. So you're even giving yourself marks. Next is the mass of calcium carbonate. So calcium oxide. So we are looking for the mass of this one formed here. Now there are 2 ways that we can find the mass of this calcium carbonate. The first method is what we call mole ratio. Mole ratio. So under mole ratio, we are going to compare the moles of this and the moles of that. So write calcium carbonate here. You say in ratio to calcium oxide. What's the number of moles given here? Is 1. And here, in here, it's just 1 as well. Now, because they are 1 to 1, get me this. Because the ratio is 1 to 1, it means even calcium oxide has 0.055 moles. I hope I've now explained that. Therefore, we can now find the mass using the same formula. Making mass the subject of formula, we have mass equal to number of moles multiplied by molar mass, which will give us 0.055 times molar mass of calcium oxide. Let's find the molar mass of calcium oxide. So we have that and that. That is 16 plus 40, which will give me 56, right? So put 56 here. So times 56, and I'm getting 3.08 grams. That's the mass of calcium oxide. If I made this video for you easy, please subscribe to my YouTube channel. Also like my Facebook page, and you can also join my group. By the way, don't forget to start my online classes with me. It's very important, because if you're writing next year, it's better you start earlier the better. Classes have started already.